Sweet. Welcome everybody to the inaugural HyperSDK developer community call. The point of these is to have a more intimate conversation with the people actually developing on the HyperSDK and really go technically deep into the code base and where it stands and how you can develop on it. This week, but we're going to talk about the roadmap a little bit, where the code base currently stands and where you can develop on it, on top of something really cool that Dariush hooked up with the EVM recently. So Patrick, I give you the floor.
Cool. Yeah, so this is a recording. I think it'll probably go out in the next few days. So I think we can probably first pull up. I'm going to share one screen. Do you mind giving me access to share since I don't?
Go for it.
Just getting this one in. All right, let me know you guys can see that. All right. Kind of
Looks
blurry.
Good. I can see it.
Is that legible? I don't know why it's so blurry. All right, hopefully it's legible enough. Yeah, disregard the other lines pointing around here. This will be like a public document that'll be shared hopefully soon. But a lot of people have been like taking stabs at integrating with different parts of the HyperSDK, and I think without knowing the full picture of where like everything is going, and there's no intention from us, or I don't think for any of the other maintainers, to try and not be clear about the direction the HyperSDK is going, especially like in an ecosystem of trying to convince as many people as possible to contribute to it. So we've been spending a lot of time lately trying to put together a clearer visual of like the direction we think that the progress should go to get to like a prod deployment. And so some of these topics here may sound familiar. Some of these topics may be newer to you. Nonetheless, wanted to just start and kind of go over a status check of where we are in the grand scheme of things. So first off, we started the HyperSDK project, probably I think it was fall 2022. So it's been some time to get to where we are today, and I think we've learned an immense amount about exactly the experience that makes sense for the type of inbound questions the community is asking and trying to get. And so we have gone through these cycles of, I think, what you would typically call coming up for air. So you'll try and build something and then like test your priors, see how on track you are, and then like kind of keep going instead of doing like a 2-year deep dive coming up and saying like, does it work? So trying to just de-risk some of like the deeper development. And so that coming up for air that we've been doing has been like periodically testing the throughput on first local networks, even with no connectivity really, just like kind of the binaries, then on like an Avalanche Go style network, and then on a distributed DevNet across different regions, and seeing what the performance ends up looking like. And every time we come up for air, we usually learn quite a bit, change a few directions of where things are going. But the goal from the beginning has always been to try and achieve, best in class performance, both from a perspective of what throughput you can achieve at a certain fee rate, and then also the fee rate at which you can achieve. And so for us, we're interested in any technologies that get us closer or better on either of those dimensions. So the last time we came up for air, though, was in, I want to say September of last year or October, when I was really trying to get some realistic performance testing results with some newer gossip stuff I had implemented around like proposer aware gossip, where basically like you'd have these blocks, the blocks would be sent out everywhere, and then you'd also try to like send transactions ahead of time to the people that would potentially include them, and then also playing around with some like kind of execute after confirmation stuff, which was a little complicated, but just to kind of see the results. And we ended up running into this issue where as I kind of talked about, and let me just share one more screen here. We ended up doing basically getting to like what we called in Vrix, like this streaming state machine replication, where we tried to like break apart the block a bit and like combo that with like distributing the mempool in a certain way. And what ended up happening was just like the eventual like end-to-end latency of distributing all that data, then verifying that, and then voting on it, then continuing that process. Really, because it slowed down the build phase. Like you had to get the block and then verify the block, get the state before you could actually just determine what to build. Was really just capping the throughput we could really get through the system. And so we would, put some big machines behind it, and count how many cores you want or whatever, and it just wouldn't use the full speed of the thing because it was just so late. It ended up being so dependent on the latency of like the actual realistic network scenario. So went back into the laboratory, and then that's what really inspired Vrix, was saying, how can we just totally break away from like the bottleneck we had been facing? And so as we went through that, that's where like kind of development really took a bit of a different direction to focus on getting Vrix to a point that it was clearly specified and justified, or explain the justification, and then actually clearly get into like what a Vrix style deployment would look like. So since then, since the publication of that, which took probably 3 months or so to write up and fully kind of come together on, I've been working on implementing Vrix in the HyperSDK and like working through the spec to make sure it's accurate, while concurrently working with Dariush, Richard, David, some other folks on functionality related to the HyperSDK. So that's the parallel execution stuff, that's like the program support, that's the Solidity support inside of the HyperSDK, which can proceed kind of concurrently with this like deeper core related work. So yeah, my hope is that we get to this integration ready point sometime in Q2, where like the interface between like the core components of the HyperSDK and like what the integrators actually end up building becomes more hardened. So like you're not the like number of deeper annoying changes, like the interface kind of stop, and then you can really start to build around the core. And so that's the milestone we're currently trying to work towards. And then at that point, it should be, build all the VMs you really want to without having to worry about much rework. And then in the developer ready phase, it's something where we have like reproducible load tests that are really easy to use, and teleporter support integrated so we can communicate with the primary network. And then at that point, we can have, production ready virtual machines good to go. And then application development is like the next phase, where we have like 1 or 2 standard hyper VMs for just deploying contracts that are running. So where you don't have to have your own virtual machine to actually create your own hyper VM. Similar to like how the Subnet EVM works. But I think the biggest thing, and I'll stop here because this is very much something of a conversation, not just like, here's our thoughts, but the big thing to call out here is this indexer driven pruning step. So one thing that's become abundantly clear as we've like done all this load testing is you can't sustain 100,000 plus TPS on your machine and expect to keep any data on that machine that isn't related to just verify the next block and helping others sync to that latest state. If you're storing more than that, like it just gets incredibly expensive to keep like all this state on the same disks as like where you're keeping the actual hot state. And so there's also like kind of slide redesign going on where we're changing the way that data is like kind of represented throughout this architecture. So you have like the HyperSDK core VM, which is really just about processing blocks and just running the chain. And then you have this interface where you can fetch basically all the artifacts from that block processing. So like the block itself, all the chunks, all the state diffs, all the like execution results, and then put those somewhere else. So whether there'll be like a separate sidecar you can run for the HyperSDK that you can have like an archival DB somewhere else, or you can just hook it up to like a SQL database or S3 or wherever you want to put that stuff. But the hope is then the indexer has this ability to then clear data from the validator or like the node that's actually running the chain so that it can keep processing at this like target throughput. So that's the only bigger change where right now, like some of the code is pretty monolithic in that like it assumes that you can just like kind of have some variant of like an archival mode, which just doesn't make sense at the throughput that we're discussing. So yeah, I think that's the brief overlay. You'll see the other database components here is like where they can hook in. Initially, the HyperSDK is going to rely on the MerkleDB, which is currently under audit with OpenZeppelin, and should be pretty close to actually being utilized here. And then at some point, Firewood, when it becomes production ready, would be a drop-in.
Another thing I would like to add also is going into the Hyper-VM developer ready. We also plan to work with other internal teams to allow for some tooling to help you abstract like wallet support and indexer support.
I have a quick question. So we see the HyperSDK programs, we see the Solidity support with the EVM. Are these use cases built out completely separate, or is it anywhere going in the direction of, I think, is it Arbitrum that builds something like it with like Solidity and WASM coexist in one VM?
So that would be up to the Hyper-VM developer on what they want to actually like hook up in their actions. So I think our initial approach is just to have them be separate virtual machines, not ones that like intermingle. Although like the way that you could do that is possible because you have full control over like the action state layout. So like you could try to interleave them if you wanted to. Yeah, I think the idea is like to try and have these like very well abstracted like code execution pipelines, and then you can just like sample them or like dabble however you choose to hook them up to like the chain itself. Where hopefully they also set a good example for people to just hook up other things too, like whether that be risk whatever stuff or ZK stuff or anything. It'd be really cool to have like some sort of like higher level interface that we come to agreement on that like makes it easier to just like plug them in, where you don't maybe even have to like do a lot of direct action development. But I think that a little further out than where we're at right now.
Would you say then that kind of the unit of like a component for the HyperSDK would be kind of like a set of actions, that it's kind of like we pull in these set of actions into the HyperSDK? Would you say like this is kind of the boundary of a component?
I think like the practical thing that we all should be very cognizant about is like it's not necessarily straightforward to like make those different sets of actions plug and play with each other. And enforcing that as a requirement just gets really hard, like really hard. Like I think if you talk about like some of the Arbitrum stylus stuff, like in the WASM code, they like import Rust libraries to like decode Ethereum function calls, and like imagine that, but like multiplied by like 15 different like program style virtual machines, like nuts. Now the whole point here is for like the HyperSDK to be generic enough that if you want to fight that battle, like Godspeed, good luck. Like, but the idea is that I just want to make it clear that I think more pessimistic on like all this like matching of different virtual machines. I think it's a much more elegant experience to have really like one programming environment per chain, and then if you want to like go to different programming environments, you like do like a warp transfer or teleporter message to another environment. But that's my opinion, and that's why we don't. That's why the Hyper-VM part's open. Yeah, Noah.
Yep, I just wanted to know kind of on. I know you said Q2 for integration ready. If you could kind of rank like how different things are going to implement. I know it's kind of different teams work on different things, but if like you could rank it and say like, we think Varix can be done first, EVM second, how is that kind of looking on your guys' end, and how are you guys thinking about the roadmap on it? Especially because we'd be happy to contribute as well at NodeKit. We have a few developers that
Yeah.
code on HyperSDK and code on Seek, we'd be happy to contribute.
Yeah, I think like the one that is not really being touched right now is the indexer driven pruning handling. So there's basically, in a nutshell, like the HyperSDK code base right now is like this, and we really need it to be kind of like this. And my focus and most of the team's focus is very much on like the processing part, less so on like the handling of the data part, which can be totally disconnected, really. Like, I'm just going to hand you some blocks, some chunks, and then you can determine like however you want to store that, like whether that be in SQL, on disk, on whatever. And so I think that everything on that side of the abstraction is probably going to be, pretty flexible, pretty open, and like different sidecars and different things for doing stuff like that. I would imagine that that'll be once we get a little bit further along and like I establish the wire format for like sending the data from like the processing part to the indexer part, that it should be a really interesting place to develop, because there's going to be a lot of stuff to do there, whether that be like HyperSDK generic endpoints and stuff, or just like very specific virtual machine endpoints, and like trying to create frameworks around doing that scalably, because it's a new concept. Like I'm not familiar with a lot of people that do it. I think the closest I've heard of is like Stellar's Horizon server, where like they kind of have this like separate wrapper component around like this core like kind of validator engine. But I think that this is even at a different level than that. So I would say like that sort of separate component is going to be a great place for like there to be a multiple different options that are just super tailor made for like one type of view of like how that data should be stored. Like one, for example, is we have the archival DB or archive DB inside of Avalanche Go, which is similar to like some of like the Aragon style state DB, where like you can't generate proofs on historical data, but you can do like really fast lookups of like old state values. Like you could definitely use that to power some like standard endpoints. But some other people may say like, I don't really want to have any disks I'm maintaining on the cloud other than like the node that I'm using to process data. And I just want to use like Bigtable. I want to use like Postgres, or I want to use, whatever, some data lake on top of S3 behind the scenes. And I think that you'll just be different kind of handlers. I don't really know what we'll call those things yet, but that's the part that's going to be pretty interesting.
Yeah, we've seen the same thing on our end, because we've implemented S3 support, Postgres support, and now SQLite support for HyperSDK for different data handling, and still figuring out some of the bits and pieces on that, because we kind of focus on the exact opposite side of not as much on the execution side. There is some work on there, but most of our stuff is around the data handling and the data processing and kind of the JSON RPC, because getting it all not standardized, but standardized for kind of our use case, and making sure that we define the endpoints for our users so we can build the integrations on top of it and not be worried about like, oh, that's going to change a ton. So we work on kind of that opposite side.
Yeah, so you can expect that like the way the code base is going, that'll just be much better abstracted for you. And it'll be much easier to just maintain that code in a totally separate place. So like the way that, well, at least the target for me is like that endpoint on the HyperSDK is really just like really stupid. Like it doesn't do anything. You query a block height, you get all this massive response back to you, and then it's up to you to determine what that is, and then to delete it from the validator, like when you've persisted it in some way. But then from there, like, good luck. I think like the big pain point we've seen or had ourselves, and I've run into this a number of times, is the EVM kind of equivalent to like what you really need to do this right is the trace endpoint. And like the way the trace endpoint works is it like re-executes whatever was the state at that time. So like if you actually wanted to like get that data, you have to like go now like walk back like your current state all the way back to that point, rerun all the transactions at that height, and then send it out with some like non-standard output based on like some sort of trace call. The way that this will work instead is we're actually just going to give you like the entire state diffs, like all of the execution results, and just persist them as the block is processed, and then never re-execute anything. And so you'll just be able to like
That's an
get
interesting
these.
approach.
we're like these results, and then you can just, it'll have everything you need, and it will be really fast, super easily cacheable. And so there'll be like this need potentially to store these raw things somewhere for like people indexing the chain. They can just come and just grab them all. Like you don't have to go think a node, call. Ideally, there's some way we can do that where we can like checkpoint the output result into like the chain itself, so that you can then verify without actually having to trust the data indexer that all of those chunks are valid.
Yeah, that makes sense. I think kind of we're thinking about it is we're looking to kind of time, especially if they get index-driven pruning stuff, time-based stuff, because we don't necessarily want to be storing it for too long. We want to make sure that they're persisting it. So essentially what we've decided to do, and sorry for any of the validators on the call, is we're having a sidecar the validators run. And it's basically, if the validators don't run the sidecar, they don't get the rewards for block rewards. And we're going to end up looking into how we can implement that functionality. But that makes it a little bit easier for a lot of the other things, because then you don't have to worry about like, oh, is this data ever getting persisted? Just having the validators persisted in this sidecar, because otherwise it's validators that want to do these things. So yeah.
Yeah,
Figuring out
we try to stay
how-
away
how
from
that works.
time ones, at least for the indexer part, just because like we've also seen, right, like, oh, some cloud provider you're using to store everything has an outage, or like, you know, the node goes down or whatever, and then all of a sudden, like, whoops, you're past the the timer, the data's gone now on everywhere. So
Yeah,
yeah, that's the only other side of that.
that makes sense. We're also looking into how validators can kind of store data individually for themselves, because we don't want to have one central place of just all the validators use one bucket. We're more so looking into like each validator runs their own bucket or their own Postgres instance or something like that, even though that might
Yep.
be more expensive. Different things for different people. So,
Yeah, I mean, I think
interesting stuff though.
there's like this huge trade-off between like it seems like there's been less of an interest in duplication of storage, as long as like the storage you fetch is verifiable. Like I think the desire to have like sensors, like just like multiple stores, has gone down quite a bit. Like I know that some like roll up factories and like frameworks are trying to like provide the chunks and data like in CDN on top of like whatever it actually is stored, just because it's, I mean, that's what it's designed for, right? Like if you have like hashed data, like put it in CDN and just verify the hash when you get it. Do you like really need to go fetch it over like the peer wire from like everyone you're talking to? I don't know. So it's a good question and call out, because I think like for some of the less dynamic data, like whether that be old blocks, if you're trying to sync an archival node, or like even just any block in general, like you could totally back it with some sort of CDN. But it feels weird to like have every validator like configure a CDN, although technically that'd be the most like, I don't know, like independent thing to do. Like if everyone had their own kind of backend or storage system like that, that's just optimized for that. Because one other thing I was thinking about is like, if you make a request for a block or a chunk of bricks, and you like are trying not to store a ton of chunks, but you want to help the network continue to function, like you could respond with like a instead of the data itself, like a ref link to where the data is, but then the node can somehow call and then verify the response, as a way to like take load off of your node, especially if you're trying to like max out your network usage of just handling the protocol itself. So I think that whole design space is a little underdeveloped, but that's something that I've thought about at least a little bit.
If I may ask a question, guys. Jacob mentioned earlier that there will be an ecosystem around wallets, indexers, stuff like that. Does that mean that there's going to be like a higher level of generalization or standards being enforced when developing on HyperSDK? Because there is now a lot of freedom, which makes, I guess, development of a wallet pretty hard in a generic way, right?
I think that there'll be like this mix match where you have standard auth types that people can support that like will be supported by wallets. Like let's say like the ED one and like the spec P256 R1, like, and have those be very well used, like basically just standardized across different instantiations, because that's really what the wallet needs to sign and keys to store. And then for the actions, have like a JSON style or like some sort of like human readable thing that the wallet can see, but the payload is obviously going to be byte serialized in a similar way. So I would imagine that there'll be this combo where like wallets will choose what sort of auth types they want to support, and if you support that auth type, like, you know, it'll produce signatures. And then from the action perspective, like having some sort of like app store style thing where like you can have like human readable action support outside of the program SDK or EVM thing, and just be able to support these like native actions however you choose. I think like the mechanism that we eventually add for that is going to be interesting. I think like it definitely works better with an open source core, which is something that I think would be a good idea. Yeah, I think that's how I'm at least kind of thinking about it. Like, you have to remember, right? Like the transaction, the block indexing, everything like that is already standardized. The address format's already standardized. So like you can already build what I think will be a pretty interesting or like basic explorer across any hyper like chain without really understanding what's going on there. And so you can just represent like certain components because of that standardization already. So I think like you'll have this kind of maybe suboptimal UI part for things that you don't have, like where you don't add a little styling to it, but it'll work. And then like the ecosystem component is trying to find a way to like represent these actions in a way that I think makes sense. So
Yeah,
I think there's a lot of weird and interesting work done to support like some more generic interaction on Cosmos and Polkadot and Ledger. And I think that's where eventually like the biggest pain is going to be, is like how to actually build a Ledger application that works well with the HyperSDK. Because again, we'll probably need some like very standard auth modules, but then somehow convince Ledger that like you somehow have a way to represent canonically like the action format, which right now is totally open for development. So like there may just need to be like more standards enforced on like how those actions are actually specified to get that to work well. Yeah. Or we just have like 1,000 actions supported in the Ledger application, which I don't usually, they're not too happy about.
I think there's only 255 actions you can have right now.
Per VM. Yeah, and the other thing I guess to consider is like the action registry right now is, yeah, I mean, it's obviously scoped to each chain. So like trying to represent that in some interesting way where you like have a combination chain action ID number is really going to be the way that you have to represent it in the Ledger application.
I think
Yeah,
it
that's an
makes
interesting
sense to have a more opinionated version of this, like where you have more of a standard. It makes sense, and why not? Like, it's probably better with regards to interoperability and supporting multiple subnets in one go. Why not?
Yeah, I mean, I think that's the art component of these interfaces, right? Is like, if it was that easy, right? Like, I wish it was. But like, I think that there'll be various, like, I don't know. I mean, like, there's a lot of ways this goes, right? There's like frameworks that are replacements for the HyperSDK that just have totally different understandings around opinionated parts. Like, I could totally imagine people, for example, I was having this conversation yesterday, like forking the HyperSDK pre-bricks, not doing the decoupled state machine replication stuff, which has like certain trade-offs, and trying to opt for like a, you know, medium throughput or lighter throughput chain because it is easier to work with, or like, I don't know, just there's different constraints that you have to deal with, rather than going like full throttle with like the HyperSDK bricks. But I would imagine the same could happen for this, where it's like, hey, like, you know, that actions object you're familiar with, well, now it has more constraints. Like the actions must meet this definition, like they must have this byte format, so that like we can better standardize things in the experience. I would say like my experience with this has been keep it open, see what people do, and then try to standardize around what people do rather than the other way around. But you know, I think we'll see how that goes. I think there's a lot of standards to try and enforce here that are not currently they're just really open.
I completely agree, man. I think it's the way to go. It's good to leave it open. I think it makes sense to allow actions in the first place, because not every VM is gonna want to support programs or have EVM compatibility at all for hyper-focused applications. And having kind of a freedom in that sense makes sense, but the opinionated freedom will make it more balanced, right?
Yeah, we were having some conversations too around what is your minimum viable VM for just like minting tokens and issuing rewards and stuff like that. Looks a lot different than like a program enabled one. And so, it's just a lot more efficient to have if you just manipulate the keys directly, like you can go real fast. But the flexibility, I think, is always the question mark, which is why it makes sense to still support that programming environment, or hopefully provide execution environments that you can just choose how you want to incorporate. Maybe it makes sense to give a quick walkthrough of like some of the stuff we're playing around with in the validity side of things. I don't know, Dariush, if you want to talk about this, or I'm happy to kind of walk through some of this for you.
Yeah, feel free to overview. Just started this work really. There's a lot of
It's tough to hear you a bit. There you go.
Yeah, not sure. Yeah, maybe it's better back there. Not really.
Yeah, it sounds like you're talking like 10 feet away from a tin can. I don't know if there's anything you can do to fix that.
Okay, this is like that might.
I think he said he was going to get his headphones. I think I got
Sounds
that.
good. Anyone have any questions in the meantime? I'll try it again.
Hello.
Oh,
All right, I think
way better. Way better.
Yeah, so I just started this work. There's like a lot of places where things can be incompatible with the EVM, like especially around expectations about what we will do with block hashes or accessing to the base fee. But I think the idea of executing the bytecode is going to be, following the bytecode interpreter that's implemented in Geth. But like with regards to transaction formats or how we will trace the state keys or how the state will be laid out, all of this is pretty much under development. So if anyone has any ideas here, participation is open and welcome, of course. Otherwise, I'll try my best.
Yeah, this one is there's like one interesting call out we were talking about last night too, which was around like the gas pricing for like storage operations, because like the HyperSDK already charges you for storage operation. So there's definitely some interesting loose ends to work out around like even like op pricing as you adapt it to this model.
Yeah, we'll probably change like the storage opcodes to not charge that much. And we'll charge the HyperSDK fees instead.
Yeah. The other complexity too is like because the HyperSDK requires state keys to be fully specified in the transaction, like trying to pull the state keys that are used in a trace or something like it, and then storing it in the actual transaction itself is also another fun wrinkle of things. But the fun part is it's natively parallel. So like if you just hook it up, you're good to go. Yep, Josh. That's the meat of the logic here. This execute call.
Hi there. I'm just trying to understand the high level path through to the EVM. So is it imagined that you would start off in an action, do the EVM call, and then come back to the actions for persistence, or is the persistence that then calls back to HyperSDK? I'm just trying to understand what the imagined process flow is.
Mm-hmm. Yeah, so essentially what I'm thinking is that we map the state to the EVM state. So all the storage will be inside of the MerkleDB, and there will be a mapping between the keys of the MerkleDB and the EVM state keys, more or less a one-to-one mapping. We will use the StateDB implementation from Geth, but not their databases in any format. So as soon as the transaction is completed within the EVM, we'll take all of the changes that would have been applied to the Geth trie and then apply them to the HyperVM's database. Not sure if that answers your question.
Does that mean that the return value of an EVM call would be just kind of like a map of state keys and then new values?
Effectively, yes, but it would not be communicated that way. So the EVM would just run its own code the way it does for maximum compatibility.
Yeah, the way that you should think about this is it's almost like splicing in this kind of arbitrary execution component within the HyperSDK transaction format, block format, state format, and everything. The HyperSDK has no idea that it's running the EVM, just like it has no idea that it's running any particular action. And so the trick with any action, right, is figuring out how you want to map the state changes that it causes into the actual state you have access to that is then synchronized throughout the network. And as long as that state is deterministic, you're good to do whatever you want to do. Now, the trick usually for people is making sure that state's deterministic, but that's as long as that's the case, you can hook up anything to the actual action processing. And so in this case, it instantiates a little mini call to the EVM, runs the EVM, and then just takes the output, puts it somewhere. But none of the other stuff is maintained. So the transaction format of the EVM isn't maintained. Block format of the EVM isn't maintained. The trie-use structure of the thing isn't maintained. But what you can do is take your Solidity contract and run it. And we have found that to be the pivot point for most people that are interested in this sort of thing. Is they're hey, some EVM's cool, but whenever I try to really ramp up the juice, doesn't really do it. But I actually really don't care what's going on behind the scenes, but I just want to run this contract. Can I do that? And so this is very much for those people. Noah, I think you were next. There's some sort of queue here. Oh, cool.
Yeah, I was just wondering, what's the performance going to look like, and when can we kind of expect this to be more fleshed out, more usable right now, or any documentation? I'd love to read up on it. It seems super interesting. It's really exciting stuff.
This one is definitely early in the development phase. I definitely wouldn't be ready for use, stable usage prior to the integration ready phase, I would say. So it's probably a late Q2 to early Q3 phenomena, I would say. I don't know, Dariush, if that sounds right. Maybe we go faster, but I think there's some edge cases to do it right. The tough part with any of these changes, right, is they affect state. So it's tough to change little things about it after you start to use it, because the migrations are typically non-trivial. So that's usually the reason for maybe a delay that is longer than you expect, is to say, well, when we really launch it, we really want that to look right. Now, there's an alternative where we try to make migrations of state of first class parties supported by HyperSDK, so you can frequently update stuff, but whoa, that sounds crazy. So, but it's possible you could do that if you wanted to, and take downtime to run migrations every time there's an upgrade or something. I don't know, Dariush, if you have anything you want to add to that.
Yeah, I mean, for throwaway stuff, we can run anything. I think we might go through a phase of having it run throwaway, because even within the bytecode compatibility, there's still stuff that can depend on context outside of it. and there's always like leaky abstractions. So I imagine we will encounter a lot of that as contracts are deployed and like expectations are not met. So I would definitely not recommend it for anything that you're not comfortable like deleting, but otherwise, feel free to, use what you want to use or do what you want to do.
Thanks. Super cool stuff.
I think there's this happy path where somehow like the RIC stuff, the indexer driven development and the Solidity stuff and program stuff just kind of all meet up the same spot, and you can really do some crazy stuff all at once, all of a sudden. But I think the idea here is to say the HyperSDK is optimized all in for like Avalanche specific stuff. Like you can do whatever you want to do on your own, but it would be, I think, naive to say like there isn't interest in taking Solidity you've spent like millions of dollars auditing and running it as like your program, or you already have people that know Solidity and you just want to do it even if you don't love the abstractions. And I think it offers like a really nice bridge for people to come into the like HyperSDK world where like they don't really have to think about what's going on and they just get way better price to performance. And the program SDK, which we haven't talked much about, is very much on the other side, which is to say, what if we were to just build something from the ground up that was optimized for Avalanche on its own? Like, what does that look like? Some people may say like, well, it sounds like a whole new thing. Not interested. I want to just like take my Solidity, and other people are like, yeah, I'm just so sick of it. I want to try something else that has like native reentrancy protection, native, whatever. So we'll see. Let the market decide, I think, is really what I'm trying to say. Tall. Scared him off. See here. Hey, Richard, do you want to give an? Oh, there you go. Now we can hear you. Go ahead.
Sorry about that. Speaking of things that you don't have to think about, what's going on in the HyperSDK, I'm thinking of practicing out just building a regular Hyper VM, not a non-program VM. What would be a good idea to practice with that if we're comfortable with the Morpheus VM and we want to create something on the same intermediate level as the token VM?
Good question. So I had thought about the token VM as like the next evolution of like what you probably want to do with the chain, which is like token issuance, token trading. I think like other things I've been really interested in are like mirroring this world of this like data incentivization problem you get. So, I mean, this is very much your open world, right, that you want to do. But like what has become very popular lately, you've probably seen, is like this surge in interest in ActivityPub. So I don't know if you've followed ActivityPub at all, but like it's this whole new kind of like framework that a lot of different social players are trying to adopt to like standardize social network integrations between like regions of social networks. And right now, like there is no way to provide I guess like more security around like the feed of them, or like to try and establish some form of like useful originality between regions of like networks doing ActivityPub. So like having like a social on-chain component that uses like the better scalability of RICs would be interesting to establish like a useful originality of ideas. So if you're interested in some of that tangent, I worked on a paper a while ago. And it'd be really cool to see this come to life. 1 second. Yeah, check this out. See if I can share my screen. So this is like kind of a morph of a few things, but long story short, I think there's like usefulness on like trying to increase the penetration of hash addressable data. The issue is like discovering hash addressable data is not like a great or well solved problem right now. And so I've always been pretty interested in like trying to provide some notion of like usefulness or like kind of an overlay layer on top of context addressable data. And typically the way you want to do that is like have some, like there are a lot of reasons why you want to could have a blockchain involved. But one of the ones is I write about here, which this is from a long time ago, so excuse any like super dated references, but the idea that you can have usefulness from basically aligning the interests or like the preferences of people that don't know each other if one of the people finds data that's interesting before you. So let's say that, you know, I find some like cool image or some meme or something. Usually this is most of these examples are best explained with memes. So let's say you find a cool meme or like you create a cool meme, you upload it. You're the first person that did that and you pay some like fee to like do so. So there's like some sort of like cost to like uploading content. So you can't just like scrape a whole website and upload like 500,000 links or something. You put the content there, and then let's say at some point in time, for some reason, that content is serviced to me, and I'm like, oh, this is interesting. Like, this is a cool content. I like it. Well, I should now give you some sort of reputation in the system as being the first person to like originate useful content to me. And so if you have like a shared layer of truth, aka like this blockchain ledger, you can all agree who discovered content first. So I played around with some of these ideas a bit in this instantiation of this for the HyperSDK a while ago called the index VM, but it's super out of date and hasn't been updated since like the first release really. And it had some of the same ideas, but I would just say like doing cool stuff with content on the internet that isn't about like token and value.
Yeah, that sounds super interesting. I'm gonna take a look at it. I want to maintain like a version, like a VM of myself that should be back tested against the HyperSDK each time, so that you know, I'll know what to change in the future based on, you know, what happens with bricks, because I know you guys are back testing with Morpheus and Token, but I want to have my own as well to kind of include in that batch if possible.
Yeah. I mean, yeah, my guess would be just some sort of like basic social thing, or messages. Even yeah, the simplest alternative here would be just like some sort of like message relay system where you can just post bytes. So not like token transfers, not like anything like that, but like somehow bytes. You can just add bytes and annotate bytes would be my recommendation if you're trying to do like some sort of basic extension to the Morpheus VM. Just because it's not token based, and so I think that you'll get some like interesting edge cases that you may run into if you are like trying to deal more with data than you are trying to deal with than with tokens.
Yeah, that's
especially if you start adding proofs into the state, like so you can like have a tree of messages that are outputted in each block, and then you can prove against like the messages somehow. It obviously depends on how crazy you want to get here, but
I have some strengths in like ZK stuff, so I'm trying to apply it wherever I can inside of VM if possible. But it needs to be intermediate because I have to be able to, you know, I understand the Morpheus VM, but so I have to progress to the next level of VM. So I'll take a look at the things you've shared. And
if you're trying to do ZK stuff, like a NARC verifier in the HyperSDK action would be top notch.
We were looking at doing something with the ZK apps from Mina to test it out, but like, yeah, I could do that as well. But just
the NARC one may be easier just because it's Golang. So like you can just pop it right in. You don't have to worry about like any FFI stuff with Rust or whatever. Like that would be sick if you had a circuit verifier on that action. So few options. You can decide what you think is most exciting. My vote's for ZK stuff.
You can also do it potentially inside one of the WASM smart contracts. We looked into that in the past, and that gets really exciting. So There's a team. I don't know if they want to be named. So and they're not on this call today. But if anybody wants to talk to a team that's doing decentralized ZK proving, and they're looking into HyperSDK, I know the team. They're not really public about it yet, but they're doing some really cool stuff. So if you're looking into trying to use like ZK proving on it, I think they'd be glad to chat. They focus a lot on Nova. It's really interesting stuff. We're really excited about it.
You're talking Supernova, or is that Nova?
Yeah, it's the guys behind Supernova.
Okay, yeah, that's glad you chose to that. Yeah, that's super exciting for you. I'm going more pie in the sky, trying to figure out more PCD stuff with a NARC library that I want to be using. So we'll see. Great advice.
Yeah.
Thanks for the feedback.
Yeah, the WASM stuff will be useful, but it's definitely not going to be as performant as running just the machine code, which you'll get from like having the Golang NARC library compiled. So just as a performance aside, I would expect that to be faster. Obviously, there's a bajillion caveats there in terms of like ZK technology, but nonetheless, that's just one aside. Good question. Yeah, top of my wish list is probably outside of like more ecosystem related stuff would be like a ZK example where you're pretty much using the like the data distribution and like execution capabilities of the HyperSDK to verify circuits, but then like you can just take all the execution complexity elsewhere or just get rid of it and use just the ZK verify and have like some prover that just like submits proofs to the system.
Yeah, that's very similar to how I've been thinking about it.
Cool. Well, hope to see that up next week. Anyone else?
One thing I did want to add on that is I know that Stephen Gates had worked on in the past with their VM and they had kind of the web interface. It would be interesting. I know we talked about it prior, like the wallet stuff. I think it would be interesting if at some point there was some kind of web interface for wallets for it. I know that a lot of people could build it out. I know the auth methods are kind of there right now, but I do think that could get really interesting, especially like when it's getting developer ready, being able to also have kind of wallet standard that like maybe not, it's not gonna be wallet standard for everything, but like maybe for like at least the HyperWAS and VM, say like, okay, so this is a wallet you can use to go test your stuff. So then when people are trying to like show it off and show how all that stuff kind of works, it might just make it easier for people to get it because I know it's always nice to be able to see a little UI for it and everything. And I know there was the Hyper GUI in the past as well. So kind of expanding that out with smart contract support could be cool.
Yeah, my workaround of trying to avoid like any and all front end development was the hyper like thing, which was I could just use all the Go code I wrote and then just like somehow magically it lets you just slap an interface on that. Can't recommend Wales enough, by the way. WAILS, like top notch. Like if you really want to avoid front end work, but yeah, having a website you can just like show up at, hook up a passkey, and then issue some like random transactions with a faucet is obviously like a great way to get the message across. So I think there's definitely a lot of when we get to this point of like there'll be a lot of really fun public devnets, I think, here. And I think it would be a great time to test out all sorts of interesting like UI experiences to showcase some of the stuff. All of them probably would involve like some sort of crazy explorer that just is like firing stuff down the thing, but because that seems to be what people think is most interesting. But the actual experience of what you can get from interacting with it is going to be cool too, which is why on the token GUI, I ended up adding like a feed where you can like post stuff and then you pay for the posts with the tokens and then you have like kind of an off-chain server running that just like maintains like a top 100 and with some time dimension based on like what fees were paid. So just to like kind of showcase all the cool stuff you can do just with like a very basic token thing. And you can mint your own tokens, trade your tokens. So that's probably what we'll focus on is like the first simple basic case because people get it. I can mint a token, I can trade a token, I can use that token to tip people. Makes sense. And then we'll have just bots slamming it. But the other thing that people also were talking about doing was using trying to create like some sort of Oracle virtual machine too, which would be really nice where you just like basically ingest tons of data feeds, because that moves at a speed that would really showcase the capability of the HyperSDK. So like having like IoT sensors, like just shove in some sort of metric like every 500 milliseconds or something like that, and try to replicate some sort of like data pipeline system on top of it instead. There was also interest in that. But those are all interesting directions to go when we get to the integration ready point to showcase its capability, but more importantly, test out like what it does under stress.
Sweet. I think we're at time. So appreciate everyone joining. Really fun conversation. We haven't really decided on the cadence of these calls yet, but it seems like this one went well, and we'll definitely try to have another one.
I'd love to. It was perfect. Thank you.
Yeah, I think the only thing I'll say is sorry for the